in this video we're going to be reviewing linked lists. We're going to be just defining them very quickly and looking at some important issues that come up when we talk about linked lists. If you haven't seen them before, then I do suggest that you first go and look at another video that explains them in detail, and then come back to see this video later on when you want to review them. This is just a review for people who have seen it before. So linked lists basically allow us to maintain a list of elements. So it's one way to implement a list or a collection of data. There you could use an array, for example, to implement your data, your collection. It's a data structure, basically. It comes up often when we talk about dynamic data. So if you have problems where you deal with data that is constantly changing, so you have to add elements, remove elements from lists, then they may come up and you will have to probably use linked lists. There are basically three types of linked lists. There's the single linked list, that's the most basic type, and that's the one I'll be focusing on because all the other ones could very easily be extended from the single linked list. The single linked list basically consists of just the nodes. So each node would have the data that you're storing, so this is the most important aspect. This is basically what you're keeping track of and that you're dealing with, so the dynamic data. And in addition to the data, each node would have a pointer to the next element, so that we can keep track of the list. If we didn't have that pointer, we won't be able to traverse the list and go from one element to the other one. So every node would have the data itself and a pointer. And also, to keep track of the beginning and the end of the list, the beginning, the start of the list would have a pointer called head. So we'd have a pointer here that points to the first element of our list, and we're going to be keeping track of this element, and this will essentially constitute our linked list. When someone tells you, okay, I'm going to pass you a linked list to that function, we're basically talking about the head element. It's very similar to the root element in a tree. And also, the final element will have its next pointer point to null. This way we know that, okay, this is the final element. We could just check to see what's the next element. If it's a null, then we know that we're at the end of the list. A doubly linked list will have the exact same thing, except that it will also have, in addition to the next pointer, it will have pointers going back. So every node, let me draw it here, every node will have the data itself, pointers going to the next elements, and also pointers going backwards to the previous elements. This could be useful sometimes in certain implementations because you don't want to go back and suppose you wanted to delete an element. And we'll talk about that later on in this video. If you want to delete an element, then you will have to know what's the element preceding it, so that you could relink the list. Suppose you wanted to move this element, you have to relink the list so that you don't just break the list. And to do that, you will need to know what's the element that comes before it. If you don't have a previous element, then you'll have to retraverse the list from the beginning to find out about it, or use a different trick, and we'll see how to do that. So it can sometimes be useful, and other occasions it could be considered to be just an overhead. It's just a waste of space. So a linked list, a single linked list, does the job really well. Also, in addition to the head pointer, we can sometimes have the tail pointer, but that's optional. And then finally, the third type is the circularly linked. And this one, what it has in particular is that in addition to these pointers, the last pointer, instead of pointing to null, it would be pointing to the first element. And there won't be any head and tail. So you won't have a head and tail. And this would be your list. There is no start and there is no end. It's just a circular list. So the beginning could be anywhere, the end could be anywhere. And we're not going to talk a lot about this because it doesn't come up often, but if you do deal with it, then there's one major pitfall associated with it, and that's when you want to traverse the list, make sure you track the start, where you started. So whatever node is passed to you, and you want to traverse the entire list, so go through the entire list, make sure that you keep track of where you started. So store, okay, I'm going to store this point here, that will be my starting point. And then when you keep on going, you traverse the list, keep on following these next pointers, next, and then keep on comparing to that element that you started at the beginning. And once you find it again, then you know that you've actually reached the end of the list and you covered the entire list.